Stanley, the floor is yours.
Thank you. Good afternoon, ladies and gentlemen. I am Stanley Ko, a citizen of Hong Kong, and I come up here to raise funds for our projects and thank for Baylor University to give me a chance. I'm one of the 2 founder members of NeoMechanics Limited. It is registered in Hong Kong. And I have a colleague here, Lorraine, who operates the slide over there. I am the chairman and the CEO of the company. And I have been working closely with our inventor partner, Mr. Moses Chang, who is a Korean citizen, who had been trained by IBM back in the old days when computer was calculating mechanically. He was the chief engineer to maintain the computer room at that time. The work experience back in the old days impressed him so much that later on he invented many unique solutions to certain mechanical engineering problems. And this project is about the seal technology that was invented by Mr. Chang. Seals are everywhere and made by different materials, but they all have problems. Engine piston rings have open ends, so they must leak. Stern tip of a ship basically is only a sliding bearing. It's not really a seal, so it leaks. Rubber O-rings of hydraulic system, it seals very well, but it's easily broken, eventually leak. And the piston pump system, they use piston as a seal. So basically, no seal at all. Leak everywhere. Leak is expensive, and it costs money. It brings a lot of back factors that couldn't be overcome. So is it that we have no choice but to live with it? Not necessary. Here comes our invention, this metal seal device. Not only it saves money, but it opens many opportunities. And most of all, it's patent protected. Here you could see our seal, the cross-section. Here comes the cross-section. And from here, you could see that actually it's designed in many different sections with different diameter settings. The innermost diameter is a little bit smaller than the piston. And the outermost diameter is a little bit, again, but bigger than the cylinder. When it's installed on the piston widens the diameter. So the radial contracting tension will hold the piston all around tightly for sealing. And when installed in the cylinder, same thing happens. The cylinder narrows its diameter. So the expanding radial tension will get in touch with the cylinder surface all around. So leaves no room for leak. The touch force actually is provided by the difference of diameters. But the diameter difference is so small, so the force to be applied on the sealing surface is so gentle. It's like felt. The same happens to the piston surface. So this is a very magical phenomenon that most of the frictional drag taken away. This device is made by metal. It could stand extreme pressures from 600 degrees Celsius to minus 220 degrees Celsius. And it's proven to stand a high pressure up to 10,000 bar. And the more pressure to deal with, actually, is very simple to us. We could just make it thicker by more rounds to go against the pressure. So theoretically speaking, there's no pressure limit. In this case, ultra-high pressure could be easily achieved in low cost. When plated with gold, it could even withstand boiling, acid, or alkaline. Amazing. With this felt-like touch properties, we call this device called felt seal with a short term CFS. It has many beneficial factors on the sealing function. And very magical. It almost suits all sealing mode. And it could be widely applied to machines of various industries. Now this is a setup to show how it really seals. This is a piston of a 16 millimeter piston. We installed this seal on the one end. It has a cross-section area of about 2 cm square. We apply the force with a 7-ton jack, and then we put the piston down there into the oil tank, attached it to the gauge, and then we apply the force. And by simple calculation, we expect to have generating a pressure of 3,500 bar pressure. The result came. It's more than that. Basically, this demonstration was verified by certain accredited persons. Professor Yun from Hong Kong University of Science and Technology, and Professor Lee from Hong Kong Polytechnic University, and Dr. Zhang, a retired dean from Manchester University from UK. How much you're willing to pay for a splendid seal like this? Sorry, we're not going to sell it, not for sale. We will never sell this CFS as a commodity because as a seal, it doesn't cost much. But the true value lies on the improvement on the machine systems. Certainly, this seals technology could be applied to many different industrial machines. But we could not do everything at the same time. We could only do one thing at a time. So we decided to go into the easiest way, piston pump system. Piston pump actually is component to many important machine systems. So if we could improve the piston pump system, we improve the machines. So take a look of the current piston pump system. This is an inside view of the piston pump. So the piston is moving so quickly inside the cylinder, it could not be sealed. And the worst thing comes. The scratch between the piston and cylinder makes the leak problem more seriously. So piston pump is an expensive machine to maintain. Downtime unavoidable. A lot of spare parts, labor costs, you have to consider it. So think of a contractor company who owns 50 excavators. How much cost they have to maintain these excavators a year? I could tell you now that our technology could save it all. It's very simple and easy to apply our technology into the piston pump system. Just put our seal onto one end of the piston and put it back into the cylinder. So only the rim of our seal will be in touch with the cylinder. So friction will be reduced to minimal. This is the current model, 1,000 bar water, high pressure water jet producing in China now. So see ours. It's simplified a lot, and you take a note of their difference of sizes. Just of this design, we save 30% production cost. Piston pump is used to produce pressure, but it leaks. But our piston pump, CFS piston pump, will produce high pressure. It's very simple because we make use of the previous leak as part of the pressure. And there will be no more to use expensive, low heat coefficient alloy to make the pistons and cylinder. So we save a lot of production costs. This principle applies to all kinds of piston pump system. In the world market, high pressure piston pump, high pressure water piston pump, we have a total market size of 2 billion in the whole world. But since this is a pistons pump system we could improve, we could think of also the hydraulic pump, 50 million a year, 20 million a year, and fuel injection pump, 70 million a year. And with this system, we could provide immense water flow as well as pressure. So we could be better firefighting pump than centrifugal pump. So it takes a whole of more than 100 billion US dollar market size, a big opportunity. We have finished the R&D phase. And this is the best time for investors to join us because we are about to launch our products and start our marketing phase. And then we anticipate in about 1 year's time, we will start our mass production phase. We are in alliance with a pump factory in China, Tianjin High Pressure Piston Pump Factory. They have been in the industry for more than 20 years. They know who's and who in the industry, and they have enough customer base all over China. And then they can bring us industrial market access. And then through this piston pump factory, I talked to some users of piston pump. And I explained our innovation to them. They all get excited. They promised me they would try our pump when our pumps are ready. And if it is as good as what I told them, they will shift to use our pumps. Okay. Also, we have an alliance with the NeoMechanics, a Hong Kong-based engineering company. They have their head office in Hong Kong and factory in Shenzhen. They could help us from A to Z to produce new models, from AutoCAD drawing, machining, assembling, and testing. And then we have an alliance with Sighting Corporation in US and Chinda Trading Company in Shenzhen to do the marketing for us inside and outside of China. We have designs of these models ready, and the 1,000 bar pump is under progress. It will be finished by the end of this summer, and then at the end of the year, we'll have the other 3 models finished. And the end of the first quarter next year, we'll have the cement pump model. About cement pump, that's a very interesting figure that I would like to tell you. About 10 years ago, China started to produce their own cement pump. The selling price was about half to the cheapest import model from Japan. But now the price falls to about 1/3, but still not selling well. This is the reason. Their seal could only last for 100 hours. Think if you're a contractor, can you stand it? And you can guarantee the lifetime of CFS for 10,000 hours. This is our forecast of our sales. In the beginning few years, we will sell like a small pump factory in China, like an average pump factory. So we won't expect to sell more than that. And in the first 3 years, when the customers realize there are models that are very different from what they are using now, then they will try to use ours. It's like additive. Once they use our pumps, they could not use others. So we'll focus in the domestic market in the first 3 years and give us enough time to prepare ourselves for the international market. And after which, we'll expect a business boom. This graph is based on the sales analysis, and the figures in black are the net profits. So from here, we could pay back the $3 million investment amount in the 3 years' time. We have a professional and qualified management team who all of us believe that this technology will bring human beings a bright and good future. And this is our compact scientist little group that they join together to apply this technology to all different industrial machines. And then they really mean to change the world. When we are ready, that in the future, not very long time, in the future, maybe a few years later, and then we will start to grow into other fields of machines, one by one. And those will be the real time for us to change the world for good. And thank you for your patience.
Thank you very much for your presentation. I kind of used the analogy of the razor blade kind of analogy, where you have the razor and you're trying to create the razor blade. Or you have the blade, but you're trying to create the razor blade so that you can sell more of the blades.
The blades?
The blades, which is the CFS.
Okay.
Maybe this is not a good analogy, because obviously your seal technology has much more IP than a blade. But
I see.
I'm struggling to understand, is your vision and is your company the seal technology company, or are you trying to be a...
Actually, we are a mechanical engineering company. It's not a seal company. Actually, seal is only a little part of our technology. It came from a series of technology. Actually, it started from engine. And actually, this engine technology was inspired, Moses got inspired when he was in IBM. The computers using the compressor to provide the power for calculation. But at that time, the workers inside the computer room, a top-tier scientist, it was pity that none of them could talk to each other because of the noise. So he was the chief engineer over there. He has to solve the problem. But he couldn't make it during his service time in IBM. So later on, he invented the method to make the piston and connecting rod going up and down vertically without scratching on the side of the piston. So we make a very quiet engine. Other than the compressor, actually it's an engine, right? And then he got the first patent in 1996. But we were naive that we tried to sell this technology to the automobile company. At that time, we were welcome and with enthusiasm, but nobody really wanted to pay the money for us to go through the AAA certificate. And then we almost went bankrupt, and then we decided to maintain our R&D, and then we went for the cheapest part, the seal. And then eventually we found that the seal has bigger opportunity than the piston and connecting rod.
Thank you for the clarification. I do think your presentation was very good. I just think that the way you started off, to me, it seemed like you were initially a seal technology company. And then you even said, if I recall, that because this seal cannot be sold for very much money, we're going to put it into a system.
Yeah.
So I think if you could just kind of reposition your presentation next time to be a little bit more of, give us a vision of what this company really is.
Okay.
As opposed to just focusing on a technology, but really what kind of product are you developing? The product piece came in later, and the way you started off, it just kind of confused me as to what kind of company you were really trying to be.
Yeah, thanks.
Yeah, I'd like to echo that. I'm not sure, I understood you said you were not going to sell the seal, but then you later said you're partnering with a engine manufacturer or a pump manufacturer.
Yeah.
So how do they get your seals in order to put it into your pump?
We don't supply our seals to their products. And we only supply the seals to our own products, which I will assign them to OEM for us. And we are not pump people. We don't know who's who in the industry. So we have to be in partnership with a pump factory in China to bring us into the business. So it's about the mutual benefit between the two companies, that they OEM for us, they make the money first, and then they bring us to the marketing, then they could share a bite from our sales.
So they're making pumps to your specifications using your seals?
Yes.
Okay.
Yeah, and they're willing to do so because they know that when our pumps come to market, factories like that will be finished. So they don't want to be the one be kicked out. So they grab us as soon as possible to make sure that we'll give them the order, we'll do the marketing with them, we'll do the sales with them.
So then can you sell your pumps for a premium to the same pumps that they're making without your seals?
Those pumps they are making now in China, they are using very old technology. Actually, it's a overall situation. There are about 40 piston pump factories in China. Only a couple of them are joint ventures with the German or with the Japanese. So the rest are using very primitive design, about 50 years old from Russia. So they are making it. But actually, I tell you, they are using seals. Because without seal, it just couldn't move. But the seal is like really felt. It could last for maybe a couple of 100 hours. So we could not tell it is sealed. It's just some device to fix the clearance, to hold it like a bearing. But it's, the pistons just grab it continuously. So even water pump, they could not just compete with the world market. No way. But we go in with our technology, with their manufacturing capacity, we could produce even hydraulic pumps and even the highest end fuel injection pump. Fuel injection pump is now dominated by 4 major companies in the world. And not so many people could do that. But we have a very destructive technology because we don't care whether the piston will expand or block inside the cylinder because we have the seal as in between, buffer. So our manufacturing cost will be very low, and manufacturing method actually very primitive. No need to have a high-grade polishing. And then we just use normal machine steel to do it. The fuel injection pump in your car, they are using very special alloy, the low heat coefficient alloy. It is 30 times more expensive than steel. So when our fuel injection pump comes to the market, it's very destructive. They either come to join with us, or they will be out of market.
So is your pump more expensive?
As I told you, The seal, compared with the O-ring, of course, we are many, many times more
So
expensive.
to the customer. So do you
No,
sell
no,
it
no.
to the customer for
We,
more money, or you sell it?
actually, we take the benefit from lowering the manufacturing cost already, so we don't have to raise the price. So this pricing strategy actually also very destructive, because the other pump factories just couldn't compete. They either come to join us, or they buy the loyalty from us. Otherwise, they have to think of doing something else, not piston pump.
Hi.
So just, I'm sorry. What's up? Okay. Stanley, thank you. Just so I can understand your business model, the partners or the OEMs will actually manufacture the pumps for you.
Yeah.
You will provide them the
design.
and seals.
We produce our own seals.
You produce your own seals. You
Yeah.
provide that to the OEMs to integrate
Yes,
into the
yes.
actual pumps.
Yeah.
And so basically, you're kind of like licensing your seals to the OEM, and they share some of the revenue with you when they sell these pumps?
Yeah. And actually, we are thinking to set up a sales company with them that they like a shareholder partner, that we sell the pump together. Well, to bind together, that we have a mutual benefit. This is the best way to do business, I think. In doing so, they will make better money than just making their old type pumps. Actually, this factory is now producing high-graded piston pumps for certain big pump factories in China, not necessarily the piston pump type. For example, some are producing pumps for the oil field, some for the municipal cleaning, for the sewage cleaning, that kind of machinery buyers. They buy piston pumps from Tianjin, and then they put on with their peripheral products to make it their product. That's why Tianjin factory is selling to many different industries at the same time. Some of them sold users directly, some sold to the machinery companies.
So I realized you made it very clear that you're not a seal company. I understand that. But I have to say the science, the engineering of the seal is fantastic the way you describe it. I mean, I'm not, it's not my area, but it sounds.
Okay.
So well, let me finish my question.
Okay, sorry.
So I'm very comfortable with that. But then I got a little bit lost. And this question about the business model, I realized that's my problem. I'm not sure how you get money. I'm not sure what you would do to get money.
Okay. First of all, in China, there's about 10 billion RMB market size of the piston pump product. It's about 1.6 billion US dollar, and good enough for a startup company like us. And we could reduce the production cost like almost 1/3. So, but our performance is better than the imported pumps. So we get a very wide range of room for our pricing strategy. So at the beginning, we compete with the local make pump, we sell cheap. And then later on, we change the shape of the pump and make it a higher end pump. Then we compete with the imported products, so with a better profit margin.
So is NeoMechanics revenue based on the volume of pumps?
Yeah.
The pumps sold?
Yeah.
The price times the number. That's how you make your money.
Yeah.
Okay.
Not the seal. Not the seal.
Right. Okay. So it's pumps.
Yeah.
Okay. Thank you.
And I have the real sample of the seal installed on the cylinder that you could move the piston just by hand, and you could feel the suction force. And then maybe you could have a little look on that. And from here you could see a the brass thing inside is the seal. And I could take it out later on. The brass thing inside is a seal. One seal, usually in a hydraulic system, they use a series of different O-rings to perform different sealing functions. Here we use just one seal, and then maybe you could lend me your palm. Okay. Now you raise this up. Now okay, you can see the suction force, right? If it is perfect vacuum inside, with the diameter like this, you only need like a kilogram force to put it up. But because on a palm, it's not perfect sealed, right? So it's easy for you to put it up. But since this is sealed, you could feel the suction inside, right? Yeah. And then the one thing more important is like this. If it's rubber O-ring inside, you got to have a machine to move it. You couldn't move it just by bare hand. And this one is not a perfect piston because I lost it. I lost the better one during the car accident a couple of months ago. Then because of this pitch, I immediately make another one, make it in the shortest time without polishing, and still it worked. Still it worked. Yeah, maybe you could see. And after that, I'll show you some secret inside. And
do we have any more questions, or I think maybe we
okay.
call it.
Okay, just 1 minute. I show them the secret that actually this seal is broken, and it still seals well. Yeah. Okay. Now this is for installing this seal is very simple. Just a snap ring. I'm not an engineer, so I will do it clumsy. Really clumsy. Okay. Now this is a pressure ring with springs, just to provide the downward pressure to make sure that the seal, every layer, will get to stick to each other. So this is the secret. Actually, this is broken already. This is broken because of too many times demonstration and because of the car accident. But when we put it back together, actually, it performs like two seals. This is the part that seals the cylinder, and this is the part that seals the cylinder and the piston. So actually, we got two seals here. Even it's broken. So, you could see that there's nothing inside. Just put it in, and with this pressure ring and a snap ring. That's it. Very simple. Even more simple than the hydraulic O-ring system. And just to remind, this is a propeller shaft. Propeller shaft seal, because it's still rotating and installed outside of the ship. So you could just repair the propeller and the seal when it's floating, not say to go with a dry dock. So a lot of innovative usage. So I'm done. Sorry for time.